Saxon's Calculus Lesson 42 is about the product rule for derivatives and differentials. And then they want to do the proof of the product rule, which you can go through on your own. I'm not going to basically go through that proof. So here, however, is what happens when I am multiplying pieces of a given equation to find its derivative. So before, when we were adding and subtracting, we just found each individual part and we kept the plus or minus in between them as we derived. Multiplying, however, requires a completely different set of rules to get there. And so we basically memorize this one as a song, and it goes like this: 1d2 plus 2d1. Okay, so now let's talk our way through what that means. So we basically need to memorize that as a song or sing-songy kind of a thing, whatever works for you. So this means that whatever the first part is of this multiply set, so like we have an x and a y, we're going to rewrite the x exactly as it is, but we're going to take the derivative d of the second one, d2. So the derivative of y would go to 1. So I basically have x times 1 plus, and then the second one is y, so write the y. Take the derivative of the first one, which was x, so we turn that into 1, and that's our answer. So now that you understand the song, here is example 1. Y equals x squared sine of x, and they want you to find y prime. So since these two are multiplying together, we're going to rewrite the first one exactly. So that is x squared. And then what is the derivative of the second part, the sine x? Well, as you recall, that's memorized to cosine x. Plus, and then sine x is written 2, and then the derivative of x squared goes to 2x. And then we just need to put that in the right format. So our y prime is x squared cosine x, that one was in good shape, plus, and this 2x should be in front of the sine x because it's like the coefficient, and that is how you use the song to do the product. Example 2, if f of x equals x squared e to the x, find f prime of x. So we're again, 1 is x squared, derivative of e to the x is e to the x, plus 2, well, that's e to the x, and the derivative of x squared is 2x. And then, I should rewrite that. This is already in the right order, x squared ex plus 2x ex, to put it in the right format. So after a while, even though you're following the song, you get to the point where you write that first regardless. Just double checking I didn't have any errors in there. Good to go. Okay, example 3 says u equals natural log of x, v equals 2e to the x, and y equals u times v. Find y prime. So I don't have room to do y prime there, but y prime will be, and so it's these two things multiplying together. So if I just jot them in here, it's natural log of x times the 2e to the x. Now, when I do that and follow the song, the first part here is keep the natural log of x and derive this 2e to the x. And since e to the x remains that, then it's 2e to the x plus, and now I'm deriving this first part, which goes to 1 over x, and then again, I'm rewriting the original 2e to the x. So when these multiply together, this goes to the top, and I'm trying to see, do they write it in that way? Okay, so I do need to fix the order. Y prime is 2e to the x acting as the constant, then the natural log of x plus, and they do write the 2 in front as the coefficient, and then this e to the x over x. Yeah, that is how they wrote it. There's our answer. Now, in one of our last lessons, when we talked about the differential rather than derivative, and I made a statement that we were continuing the discussion of, but it was actually the first time we had talked about differentials. I just misread differential and derivative. You can see why that would be slightly confusing. But each of these are all in x's, and so that's why I'm not writing this dx, dx, dx with each of these, because the y prime is taking the place of I'm finding the derivative, not the differential. Just wanted to clarify that. So now in example 4, we are given f of x equals e to the x cosine of x, and then use the calculator to find the derivative of 1.2. So we need to derive it and then plug in the 1.2. So when we derive, because they're multiplying, I rewrite. I'll go ahead and put that as 1.2, but I'm not going to fill that in until later. So my first part is e to the x, and the derivative of cosine goes to negative sine of x, and I'm going to put a parenthesis around that because that's still multiplying, plus, and then the second half is the cosine of x, and then the derivative of e to the x remains e to the x. So I might, in this case, I can fix the order, but I can also plug in the 1.2 as we go. So you really want to do e to the 1.2, and that's still multiplying with negative sine of the 1.2 plus cosine of the 1.2, and e to the 1.2 is multiplying with that. So that's a lot of calculator work. But when you finish that, you should get to approximately negative 1.89 as you practice that on your calculator. Now example 5. If g of x is e to the x root x, find g prime of 2. So again, we need to derive following the song and then plug in 2. So the first part remains e to the x. Now, before I derive this part, I need to actually fix it so that it says e to the x, and then this is x to the 1/2, because remember that's an implied exponent of 1 and denominator is the root number of 2. So now when I derive that, the half comes down and it's, oops, not e, x, to the, and a half minus a whole is negative 1/2. All right, and then I have my plus 2. Okay, so the second part was, and I can write it as x to the half or the square root of x. It really doesn't matter there. And then the derivative of e to the x is still e to the x. Now we need to plug in 2. So e squared and then a half with 2 to the negative 1/2 plus the square root of 2, and again e to the 2. And that's a lot more calculator work. We're getting down to the number 13.03. Before I move on from this example, though, I want to double check. They simplified this thing, and they wrote the e squared in the top over the 2 over the root 2. So they went back to square root of 2 with this, and because it was negative, they put it in the denominator. Since you're doing this on the calculator, it doesn't matter whether you rearrange it or not, but I didn't want their rearranging to throw you. And then this one, they just have flip-flopped in the order, but they did put it back as the square root of 2. All right, example 6 says S equals x squared y cubed, mercy, and then it says find ds. So again, I'm marking for derivative. So when we put the ds with this one, oh, notice that I have an x here and a y here. So I am going to need to put the specific dx, dy with these as I do it. So then we need to follow the song, 1, so rewrite x squared. Derivative of y cubed is 3y squared. And because I derived the y one, this one gets dy plus 2, so I'm rewriting y cubed, and I'm now deriving x squared, which goes to 2x, and because that was the one I derived, it was the x, so we have dx with that. And I need to put it in the right order. So ds equals 3 x squared y squared dy plus 2 is the coefficient. I'm going to put the y cubed and the x so I can kind of keep the dx and the letter with it together. They flip-flopped it. It doesn't really matter. That was just kind of my preference. So the 2, the x, the y cubed, 3. Sorry, I was reading it backwards. Okay. And then example 7. If y equals s squared sine of t, and again, I notice I have different letters, so I'm going to have to make sure I put my ds and dt with things. Find dy. So derive this equation. So it's multiplying. 1 is going to be the s squared. The derivative of sine goes to cosine of t, and that will have the dt plus 2. That's the sine of t. And then multiplying with the derivative of sine squared is 2s, and then that's going to have the ds with it. Now, do I need to rearrange anything? Coefficient is in front with the cosine t dt. Oh, yep. Okay, so it should say plus 2s sine of t ds. I guess I could have left it there. And then I'll just go ahead and rewrite that. Cosine t, and then that was dy equals all of that. Whoa. All right, then again, part B was the proof thereof. And when they do that proof, they're going back to the original f of x plus change of x minus the f of x all over change of x, and with the limit of change of x going to 0. So they're doing that with both an f equation and a g equation. And then they're plugging both of those into those formulas, and they're putting the F1 adding with the G1, manipulating all of that. A huge chunk of the middle cancels off, and then they end up getting down to what they simplify on the bottom of page 217, and that should look an awful lot like your song. 1 deriving the 2 plus 2 deriving the first one, but they've done it with that very long formula.